on the Fuji symposium because we've been working with Fuji for a long time and developed some experience with CAD EYE. So my topic is to talk about intelligent endoscopy. And I honestly believe that with the emergence of artificial intelligence, endoscopy will definitely become very smart. And this is only the beginning with polyp detection and characterization, and there's a lot more to come. So I will talk briefly about the terminology which we will use in this kind of area with artificial intelligence and machine learning and deep learning to give a quick idea to our audience as to what this means. And then briefly show you some data related to CAD EYE. For polyp detection, we call this as CAD EYE, and then CAD EYE for polyp characterization, which we call as CAD X. And then show some videos. So what exactly is artificial intelligence? It's basically a computer, an artificial computer doing the intelligent stuff which most humans do using their own intelligence. So it's very, very broad definition. Any intelligent stuff the computer does could potentially fall under artificial intelligence. Machine learning is a type of artificial intelligence, and broadly speaking, this means that it is a technique in which there's some sort of supervised learning is performed for a computer with labeled data. These days, what is becoming very popular is deep learning because this can produce results very quickly and without much of expertise required from clinicians. So deep learning is where it uses a lot of complex neural networks to learn without or almost unsupervised data. So these are the common technologies and terminologies you will come across. I'm not going to bore you with all these differences, but just again to highlight that with machine learning, you need both labeled and unlabeled data, whereas with deep learning, it's mostly unlabeled data. So it's a very, very clever way of developing an AI algorithm. This again highlights the big differences that when you're doing machine learning, you need to feed the computer. A cat has 4 legs, a tail, pointed ears, and a flat nose, and then give pictures of the cat, and then it will start calling cat as a cat. Whereas in deep learning, you just give lots and lots of pictures of different types of cats. The computer automatically recognizes certain features which we still don't know what it recognizes in the texture of the image, the color of the image, and it starts making the diagnosis itself. So do we need AI? Now, you will have a lot of experts around the world when you ask them that do you need AI for detection of polyp? And we've been doing lots of surveys, and what we find is a lot of people say to us that they don't really need AI because they're very good at polyp detection. They never miss polyps, so we don't see the need for AI for detection. But I would like to highlight that we all miss polyps, and missed polyp results in interval cancers. And these are the whole range of reasons why we miss polyps. And if you don't believe me, this is the data here, which shows you that anywhere between 10 to 27% of the polyps are being missed. So there's a lot of variability in the polyp miss rate, but the extreme is almost up to 27%. But more or less, most people will miss between 5 to 10% of the polyp. Now, do we need to detect all these polyps? I feel yes. This is the data from the New England Journal publication a while ago, where it was shown that every 1% increase in an ADR of an endoscopist, there is a 3% reduction in the future colorectal cancer rate for the patients. So for our patients, we do need to increase our ADR. For our patients, we do need to reduce the number of polyps we miss. So it doesn't matter how good we are, there's data which shows that we all miss polyps, so we all need help. Now, what about polyp characterization? We have a lot of technologies like BLI and NBI and iScan, and there's a lot of publication which show that experts can make very good optical diagnosis. If you look at this, if you don't make an a good optical diagnosis by looking at a polyp, it can result in some sort of mismanagement of lesion, because you will either end up removing a polyp which you shouldn't remove, like a small hyperplastic polyp less than 5 millimeter in the rectosigmoid. There's no need to remove that. So that just results in increasing the cost of and putting patients at risk by removing those polyps. So the whole management of polyps could be improved if we had very good polyp characterization techniques. So how good we are? Well, there's a lot of data from expert centers showing that experts using NBI and BLI and eye scan can make an optical diagnosis as good as histology. But when we introduce into real time, this is a UK study where we showed that when we introduced in a real time after training the endoscopists, still they're not very good at making a good quality optical diagnosis. The accuracy was only 68%. This is not acceptable to introduce in real-time practice. So again, there is a real need to improve the optical diagnosis. This is where Fujifilm has made inroads by producing their AI system called CAD EYE. They have used more than 1,500 polyps to feed the algorithm. So I won't go into the details of how these things are developed, but they require a training data set. The training data set consists of more than 1,500 polyps with different types of histology and different types of morphology. This is the test data. So once they developed it, they've tested it on 225 polyps using white light and LCI to look at the detection rate. And again, on 134 different polyps to look at the accuracy of characterization, real-time characterization with CAD EYE. And what's the data? Well, here is the data, which shows that CAD EYE for detection, CAD EYE has a sensitivity of 92.9, almost 93%. They compared it with the experts and found that experts also detected 95% of these polyps. So not much of difference between CAD EYE and experts. But the most interesting fact here is that even non-experts, when they use CAD EYE, they performed as good as experts in terms of detection of polyps. So it's very interesting to see that a non-expert endoscopist can perform as good as experts with the help of CAD EYE. How about characterization of polyps? Here's the data on that. And the way the CAD EYE system works is that the detection happens on white light and LCI, and the characterization happens when you switch on the BLI mode. So I will show you the data with BLI. The sensitivity for adenoma characterization with CADX is 85%, and the experts do around 79%. So there's a marginal difference between a CADX and experts. But the most interesting fact here is that when non-experts use CADX, then they perform better than the experts. So again, a very useful addition to our armamentarium for making real-time optical diagnosis. So in conclusion, this is the first product in the market which has integrated detection as well as polyp characterization in one system. It has the performance of this is as good as experts, and the most important conclusion of this was that the non-expert endoscopists can perform to expert level when they use CAD EYE. So the system is now commercially available, and we evaluated it separately from that study in our center, primarily focusing on CADX for characterization of polyps. And what we found in our study was that we use 150 polyps of different sizes. You can see majority, 64% was than 5 millimeter, because that's where the biggest challenge in recognition of optical diagnosis is in polyps less than 5 millimeter of various different histology. And what we found is sensitivity for making an adenomatous diagnosis with CAD in our polyps was 94%, with a negative predictive value of 92%. So if you remember the ASGV criteria, these are well above those. Now, I'm not going to bore you with this very complex table, but basically what this is showing is that it performs equally well for polyps less than 5 millimeter and for polyps more than 1 millimeter. And then what about comparison with the endoscopist? So we compared the performance of CAD EYE for polyp characterization with our routine endoscopists who were all experienced detection and resection of polyp, but not necessarily experts in optical diagnosis. And you can see there's a big difference in sensitivity of 95% versus 81% for the endoscopist, with a negative predictive value of EYE around 90.6 versus 68% for the endoscopist. So again, it has performed better than our routine endoscopist in making an optical diagnosis. When we looked at PV2 criteria about the setting up of surveillance intervals with the help of CAD EYE, you can see that if you use CAD EYE for polyp characterization, you can set up your polyp surveillance on the spot with very high rate of accuracy. Doesn't matter which guidelines you use. So ladies and gentlemen and dear friends, I feel that CAD performs better than non-expert endoscopists. EVOS-based studies which we performed using the videos, and the first study I showed you which used images, we've shown that PV criteria for resect and discard, as well as the PV criteria for diagnose and leave, are met with high sensitivity and negative predictive value by CAD EYE system. So I feel that it is really ready for a real-time use, and I will show you some videos which will show you that. Here is a polyp. We're doing a withdrawal LCI, and there you can see the bounding box appears immediately before human eye can detect, and there is a polyp. It detects almost, I feel it detects before an endoscopist can find. Here's an example. We're doing a withdrawal and it finds a polyp. We go back and look at the polyp, and you can see it is definitely a polyp. We put BLI mode and immediately it gives you a diagnosis that is neoplastic in nature. This is another hyperplastic polyp. You see, it calls it immediately. The green heat map here indicates that it is a hyperplastic polyp. And you saw at the bottom of this also, it comes written very clearly that this is a hyperplastic polyp. Another quick example of another very quick detection. Despite the fluid, it's all gone green, which means it's a hyperplastic polyp. And again, a clear display at the bottom. So you can see the time lag is almost minimal. There is hardly any lag. And that's a very, very subtle, tiny polyp. It finds it. Then we'll switch over to BLI, and it shows you very clearly that it's neoplastic. You can see that yellow heat map. And then look at that. It found a second polyp at the bottom of the screen. And this is a common observation that once an endoscopist finds one polyp, if there's another polyp nearby, that usually can get missed. That's not uncommon, and that's the beauty of this system, that although the endoscopist is distracted by this polyp in front of him, the system doesn't get distracted. It will still find other polyps which endoscopist is not focusing on. So finally, to conclude, I don't think AI will replace the endoscopist, because we still need to take the responsibility of managing those polyps. But there's a real possibility that endoscopists using AI will outperform those who are not using AI. I also believe that AI can act as an expert second observer to improve the performance and outcome of the patients. So if we really care for our patients, I think AI should become part of our system to improve the care for the patients. And endoscopists will still need, so lots of people think that because of AI, we don't need to spend a lot of time in training, But unless the endoscopist is well trained to evaluate the mucosa and expose all the folds and bring out the polyps, AI will not be able to do anything. So we still need to train the endoscopist in the art of colonoscopy or endoscopy. But I think the training in optical diagnosis, training in detection of polyp, all can be made a lot smarter with the help of AI. And there are a lot more KPIs that it can measure, and that will overall improve the quality of colonoscopy. So thanks a lot. I'll stop sharing my screen so that we can take any questions.
Okay, thank you very much, Professor Bhandari, for really elegant